Question 1. Find the value of the determinant. Find the value of the determinant, and the determinant is given like that: 1, 1, 1, A, B, C, and here that is A square minus BC, B square minus CA, and C square minus AB or D. So how to solve? Very first of all, we are decomposing it. So according to the third column. So 1, 1, 1, then A, B, C, the second column, and third column is now A square, B square, C square. Then minus 1, 1, 1, here that is A, B, C, and BC, CA, and AB. So now we can write that one in that way. The first determinant is remaining the same, that is 1, 1, 1 according to the first column, the second column ABC, third column A square, B square, C square, minus in row 1 we are multiplying the A. So obviously 1 by A should be there, and that one is first row is now A into A square into ABC. The second row is multiplied with B, the third row is multiplied with C. So 1 by ABC is here, as we are multiplying the first row with A, second row with B, and third row with C. So we are dividing the determinant by ABC. Second row is now B, B square, ABC. Third row C, C square, ABC. So we can take common ABC from the third column. The first one is 1, 1, 1, A, B, C, A square, B square, C square, minus taking common ABC from the third column, then A, B, C, A square, B square, C square, 1, 1, 1. Obviously, we can now interchange the columns, and interchanging the columns of the second determinant. The first determinant 1, 1, 1, A, B, C, A square, B square, C square, minus first interchanging the third column into first, and then another interchanging of the second and third column. So suppose 1, 1, 1. So that is A square, B square, C square, A, B, C. Obviously, that should be minus 1. And again interchanging. So that is 1, 1, 1, A, B, C, A square, B square, C square, minus another interchanging of second and third column. So here also we can write that is C3 and C1. Here minus 1 whole square. So that is 1, 1, 1, A, B, C, A square, B square, C square. So that means interchanging of second column and third column. So now both are equal: 1, 1, 1, A, B, C, A square, B square, C square, minus 1, 1, 1, A, B, C, A square, B square, C square. So obviously the result is 0. Second question. Second question is the determinants. The determinants, those are 1, 1, 1, A, B, C, BCA AB and 111 ABC A square B square C square are identically equal or not. Explain. Now from the first problem. So from first problem, already we have the two determinants are identically equal. Now the third problem. We have to evaluate another determinant, that is, the question is evaluate the determinant is 1 square, 2 square, 3 square, 4 square. Here 2 square, 3 square, 4 square, 5 square. Third row 3 square, 4 square, 5 square, 6 square. Fourth row 4 square, 5 square, 6 square, 7 square. So how to evaluate? At first we are applying C4 minus C3, then C3 minus C2 and C2 minus C1. Let's check what happens. So that is, now suppose the value is delta. So 1, 4, 9, 16. The C1 remains the same. Then the second one, that is C2 minus C1. So that is 2 square minus 1 square, that means 3. 3 square minus 2 square, that means 5. 4 square minus 3 square, that is 7. And 5 square minus 4 square, that means 25 minus 16. So that is 9. Column 3, that is C3, that is C3 minus C2. That means 3 square minus 2 square. So that one is 5. Next one 7, 9, 11. And for C4, that is 7, 9, 11 and 7 square minus 6 square, that is 49 minus 36, that is 13. Now once again apply C4 minus C3 and C3 minus C2. Let's check what happens. So delta is equal to now 1, 3, 2, 2. That means we are changing the C4, column 4 minus column 3. So C4 is changing to C4 minus C3 and column 3 is changing to column 3 minus column 2. So column 1 and column 2 remaining the same. So let's write here 5, 7, 9. Then column 3. So column 3 minus column 2, 5 minus 3, 2, 7 minus 5, 2, 9 minus 7, 2, 11 minus 9, 2. Same as for column 4, that is column 4 minus column 3. So 7 minus 5, 2, 9 minus 7, 2, 11 minus 9, 2, and 13 minus 11, that is 2. So already the column 3 and column 4 both are equal. So we can simply say the determinant value is equal to 0. Let's check with the question number 4. Once again, we have to evaluate. Evaluate 265, 240, 219, then 240, 225, 198, and 219, 198, 181. We have to evaluate that one. Now, at first, apply the column 1 to column 1 minus column 2 and column 2 minus column 3. So delta is equal to now 265 minus 240, that is 25. 240 minus 225, that is 15. 219 minus 198, that is 21. For column 2, 240 minus 219, that is 21. 225 minus 198, that is 27. And 198 minus 181, that is 17. Third column remain the same after operation. Again, we apply. And now we apply the column 1 as column 1 minus column 2 and column 3, that is column 3 minus 10 of column 2. Let's check what happens. So column 1 minus column 2, that is becoming 25 minus 21, so that is 4. 15 minus 27, that is 12, minus 12. And 21 minus 17, that is also 4. Second column remain the same now. So we are keeping it aside. And then the third column. So 219 minus 210. So that is 9. 198 minus 270. So that is minus 72. 181 minus 170. So that one is 11. Now another operation, that is, okay, at first we can take the common 4 from the first column. So we are taking 4 as common. 4, 1, that is minus 3, that one, 1. Then 21, then 27, then 17. Then 9 minus 72, that is 11. Now we apply some operations. That is R2 is now R2 plus 3 R1, and here R3 is now R3 minus R1. Let's check what happens now. So after operation, we are getting here, that is 4 into 100. So R3 minus R1. So practically first one, we are changing the row 2 and row 3. So 121, 9, the first row remain the same. Row 2 is now row 2 plus 3 R1. So that one is 0. 27 plus 3 R1. So that one is now 90. And that one minus 72 plus 45. So 27, sorry. So that is minus 45. And that one is now 0. That one is now minus 4. R3 minus R1. And 11 minus 9. So that one is 2. So if we calculate, that is 4 into 90 minus 45 minus 4, 2. So that one is 4 into 180 minus 180. So the result is equal to 0. Next problem, that is question number 5. That is also the evaluation of a determinant. Evaluate square root of 13 plus square root of 3, 2 of root 5, root 5. Now the second row, root 15 plus root 26, 5, root 10, 3 plus root 65, root 15, 5. Now, how to evaluate? At first, we are taking common from C2 and C3. So, taking common square root of 5 from column 2 and column 3. So that one is now square root of 5 into square root of 5. Then that is square root of 13 plus square root of 3, square root of 15 plus square root of 26, 3 plus square root of 65. And here that one is 2, square root of 5, square root of 3, 1, square root of 2, and square root of 5. Next, we are decomposing the first column. So here we can write that one 5 cross the first column decomposition is like 26 plus 20 square root of 65, 2 square root of 5 square root of 3, 1 square root of 2 square root of 5 plus 5 into that one square root of 3 square root of 15 and that one is 3. So 2 root 5 root 3 1 root 2 root 5. Then from the first determinant and from first column of the first determinant take common of square root of 13. So that is 1 square root of 2 square root of 5. So that is 2 square root of 5 square root of 3, 1 square root of 2 square root of 5 plus 5 into from the first column of the second determinant take the common as square root of 3, 1 square root of 5 square root of 3. Second column and third column remain the same. Okay, now from the first determinant we can see the first column, column 1 and column 3 are equal. So we can say 5 into square root of 13 into 0. Then the next part, that is 5 of square root of 3. And here we are applying the operation that is C1. So C1 is now C1 minus C2. So that one is becoming 1 minus 2, that means minus 1. Square root of 5 minus square root of 5, that is 0. Square root of 3 minus square root of 3, that is 0. Second column is remaining the same. Third column is remaining the same. So the result is now 5 of root 3 into square root of 5, square root of 2, square root of 3, square root of 5. So that is 5 of root 3, and that is 5 minus root 6. So we can write it as 5 into root 3, or that is now that one must be minus 1. So minus 1 is here as a multiplier. So we can write square root of 6 minus 5. That is our answer. Next question. Now the question is, prove the following. That is the 1, 1, 1. That is the first determinant, first column, A, B, C, A square, B square, C square is equal to 1, 1, 1, A, B, C, and A square, B square, C square is equal to A minus B, B minus C, and C minus A. Now, from the very first one, that means that two determinant, we are changing the rows into columns and the columns into rows. So we get the two forms of the determinant. Two forms of the determinant. So we can say these two determinants have the same value. Now for the third part, that means that two determinants are equal to that one. At first, we are applying some operations. So apply row 2, row 2 to row 2 minus row 1, and row 3 to row 3 minus row 1. Let's check what happens. So from the very first one, if we are changing row, so here I am writing in a small, that is 1 A square. That means the very first row is remaining the same. Row 2 is now 0, B minus A, B square minus A square, and third row is also 0, C minus A, C square minus A square. So we can write that one as B minus A, B plus A into B minus A as B square minus A square, C minus A, and that one is also C plus A into C minus A. Now that one, we can take common the B minus A from the first row and from the second row the C minus A. So that one 1, 1, B plus A, C plus A. So we can write it as B minus A, C minus A into C plus A minus B minus A, or that is B minus A, C minus A, C minus B. But as our requirement is A minus B, B minus C, C minus A. So here we can also interchange that one, and that one. So that one is becoming A minus B, and then that is also minus, that is B minus C. So that is plus B minus C, taking minus from both common, and then C minus C. So that is the proof. Next problem. Here the question is like that. If X, Y, Z are all different and given that X, Y, Z, X square, Y square, Z square, 1 plus X cube, 1 plus Y cube, 1 plus Z cube is equal to 0. Proof 1 plus XYZ is equal to 0. So already we have the determinant value is equal to 0. So we can also decompose from here. So that one is now we can write X, Y, Z, that is X square, Y square, Z square, 1, 1, 1, then plus X, Y, Z, X square, Y square, Z square, X cube, Y cube, Z cube is equal to 0. Now once again interchange the very first determinant. So first column is now the third column and then interchanging the third column into second column. So 1, 1, 1, X, Y, Z, the sign remaining the same as the two interchanges occurred. So we can write it also here, that is C1 interchanging to C3 and then C2 interchanging to C3. Plus now take common of X from the first row, Y from second row, Z from the third row. So that is 1, 1, 1 the first column, then the X, Y, Z, then the X square, Y square, Z square is equal to 0. So we can take common the determinant itself from here. So we have 1 plus X, Y, Z into 1, 1, 1, X, Y, Z, X square, Y square, Z square is equal to 0. Since we have X, Y, Z are different, so we can say 1 plus X, Y, Z also equal to 0. Next problem. We have to solve the system of linear equations by Cramer's rule. And the question is like solve by Cramer's rule. That is the system of linear equations given X plus Y plus Z equal to 3, 2Y plus Z is equal to 3 and Z is equal to 1. Let's check what is the result here. So here we can rearrange the system of linear equations in that way. X plus Y plus Z is equal to 3. Then 2Y plus Z is equal to 3 and another one Z is equal to 1. So here we can say that the coefficient of X is equal to 0 here, the coefficient of X is equal to 0 here, and also the coefficient of Y is also 0 in the third equation. So our coefficient matrix or coefficient now the determinant value. And so which one is our B or the resultant? That is 3, 3, 1. That is our resultant matrix. So according to that, we are first finding the determinant of the coefficient matrix. So that is 1, 1, 1 here, 1.1, 1.1, 1.z. Then 0, 2, 1, then 0, 0, 1. So what is the value? The value is 2101 and that one is equal to 2, so that is not equal to 0. So the Cramer's rule can be applied here. So we can find out the value of x here, that is according to dx, that one just put the value of resultant column in the position of the x. So 1 0 0 or the first column is replaced by 3 3 1, then 1 2 0 1 1 1, and then divided by the determinant of the coefficient, that is 2. So we now have, that is half into, we can write 3 into 2101 minus 1 into 3111, then plus 1 into 3210. Okay, then the value is half of 3 into 2 minus 1 into 3 minus 1 plus 1 into minus 2, and that one is half of 6 minus 2 minus 2, that is 2 by 2 or 1. Same as for the y. So y is equal to now dy, that means the second column is now changing. So the first column was 1 0 0, so now second column is now 3 3 1, then 1 1 1, and determinant of d, that is 0, 2. So we can check it now, that is becoming 3 1 1 1 divided by 2 or 2 by 2, so that one is equal to 1, the same. And for z we have dz, that one is equal to 1 0 0. The first column remain the same, the second column also remain the same as like the coefficient determinant, and the third column is now 3 3 1 divided by 2. So that one is now 2 3 0 1 divided by 2, or that one 2 by 2 or 1. So already we have x equal to 1, y equal to 1, z is equal to 1. Let's check, is that right or wrong? Put the value of x 1 here, y 1 here, z 1 here, the result is 3. Same as if y is 1, then 2 into 1 is equal to 2 plus 1 is equal to 3. So the values are of x, y, z is equal to 1, 1 and 1. The next problem is also on the Cramer's rule. Solve. Let's check what is the system of linear equation, that is 3x plus 2y plus 4z is equal to 19. 2x minus y plus z is equal to 3, and 6x plus 7y minus z is equal to 17. So our resultant matrix is now, we can write in that way, that is B is equal to 19 3 17. So what is the value of D? That is according to the coefficient 3 2 4 is our first row, second row 2 minus 1 1 and third row 6, 7, -1. So the value is -1, 1, 7 -1, -2, 2, 1, 6 -1, and +4, that is 2 -1, 6, 7. Let's check what is the value is. 3 of 1 -7, -2 of -2 -6, +4, that is 14 +6, or 3 into -6 -2 into -8 +4 into 20, or -18 +16 +80 is equal to 70, so not equal to 0. So we can proceed with the Cramer's rule. So here the x is equal to, at that moment, that is dx is equal to, in place of first column we are writing the 19, 3 and 17, then 2 -1, 7, that is 4, 1 -1 divided by 78. So here 1 by 78, then 19 of -1 -1, so 1 -7 -2 into -3 -17 and +4 into 21 +17. So that is 1 by 78 minus 114 plus 40 plus 152. So the result is 78 upon 78, or 1. So x is now 1. Let's check the value of y now. So y is equal to same as dy, that means we are changing the second column. 3, 2, 6, the first column, 19, 3, 17, 4, 1, -1 divided by 17. So 1 by 78, then 3 into -3 -17, -19 into -2 -6, and +4 into 34 -18. So here the value is 1 by 78 minus 60 plus 152 plus 64 is equal to 156 upon 78, or the value is 2. Let's check the value of z. So that one is equal to dz is equal to 3, 2, 6. The first column remain the same, the second column remain the same, third column 19, 3, 17 upon 78. So 1 by 78, 3 into -17 minus 21 minus 2 into 34 minus 18 plus 19, 14 plus 6. So here that is 1 by 78 minus 114 minus 32 plus 380, or 234 upon 78, or that one is 3. So x is equal to 1, y is equal to 2, z is equal to 3. Let's check really the values are true or not. So if we put the value 1, so that one is becoming 3, that one y is equal to 2, so that one is becoming 4, and that one is 3, so that is plus 12. So 12 plus 4, 16 plus 3, that is 19. Same as another checking, if x is equal to 1, so that one is becoming 2, then -2, then plus z, that is 3, or the value is 3. So the values of x, y, z are 1, 2, and 3 respectively. The next problem, that is also based on the Cramer's rule. So the system of linear equations is given: x plus y plus z is equal to 7, x plus 2y plus 3z is equal to 16, and x plus 3y plus 4z is equal to 22. So our resultant is 7, 16, 22. So let's check what is the value of the determinant of the coefficient matrix is. According to the coefficient, that is 1, 1, 1, that is 1, 2, 3, and that is 1, 3, 4. So the value is 1 into 8 minus 9 minus 1 into 4 minus 3 plus 1 into 3 minus 2 is equal to minus 1 plus 1, or minus 1 not equal to 0. So we can proceed to the Cramer's rule. So find the value of x here, that is dx is equal to 7, 16, 22, 1, 2, 3, 1, 3, 4 upon minus 1, or we can write 7 into 8 minus 9 minus 1, 64 minus 66 plus 1 into 48 minus 44 upon minus 1, or the result is minus 7 plus 2 plus 4 upon minus 1, or minus 1 by minus 1, the result is 1. So x is equal to 1. Let's check what is the value of y. Same as, that is dy is equal to changing the second column, 7, 16, 22, 1, 3, 4 upon minus 1. So that one, 164 minus 66 minus 7, 4 minus 3 plus 1 into 22 minus 16 upon minus 1, or the result is minus 2 minus 7 plus 6 upon 1, or minus 3 upon minus 1, or 3. Let's check what is the value of z we are getting, that is dz. That means changing the third column, 1, 2, 3 is the second column, 7, 16, 22 upon minus 1. So result is here 1 into 44 minus 48 minus 1 into 22 minus 16 plus 7 into 3 minus 2 upon minus 1, or minus 4 minus 6 plus 7 of minus 1, or minus 3 upon minus 1, or 3. So we are getting x is equal to 1, y is equal to 3, z is equal to 3. Let's check really the values are true or not. Just put the value of x1 here, that is 3, we are getting 7. Same as x1, so that is 3 into 2, 6, and that is 3 into 3, 9. So 9 plus 6, 15, plus 1, 16. So the values are same. So the values of x, y, z are 1, 3, and 3 respectively.